Assalamualaikum and hi. Today I'm going to present to you the introductions of our project. Title of our project is IoT-based air pollution monitoring system by using an Arduino. Okay, this is a list number of our group members for this project. Okay, so let's proceed to the introduction. For introduction, in this project, we are going to make an IoT-based air pollution monitoring system in which we will monitor the air quality over a web server using an internet, and it will trigger an alarm when the air quality goes down beyond a certain level, means there were sufficient amounts of harmful gases are present in the air, such as the carbon dioxide, smoke, alcohol, benzene, and the NH3. So, it will show the air quality in a ppm on the LCD and as well as on a web page so that we can monitor it very easily. Previously, we have built the LPG detector using MQ6 sensor and smoke detector using MQ2 sensor, but for this time, we are using MQ135 sensor as the air quality sensor, which is the best choice for monitoring the air quality, and it can detect the most harmful gases in the air and can measure their amounts accurately. So, for this IoT project, we can monitor the pollution level from anywhere, everywhere, by using only our computer or a laptop or a mobile. We can install this system anywhere and also can trigger some device when pollutions go beyond on the some level, like we can switch on the exhaust fans or can send alert SMS or mail to the user. Okay.
Hello, my name is Lavneshwaran. I'll be talking about our project title, which is IoT-based air pollution monitoring system. So I'll be talking about the objectives. Firstly, our project is conducted to achieve a certain number of objectives. Firstly is to monitor the air pollution level using the MQ135 sensor. Okay, the MQ135 sensor is normally in air quality, to control air quality. The sensor is very good at detecting NH3, alcohol, NOx, benzene, smoke, carbon dioxide, and other gases. So that is why we have chose this sensor. It is one of the best sensor for air quality, to control air quality. Secondly, our objective is to alert all the users once the air quality in a certain area drops, because after we detect, we can see it and we will alert them for them to take precautions before exposing themselves in the certain area. Next, our objectives is to read and display the air quality on the LCD and web page. Basically, after we detect the air quality, we will read, it will read and it will display in the LCD page so everyone can see. We can use our mobile phones, laptops, everything. We can see it anywhere in the display.
Assalamualaikum, my name is Muhammad Arif. Today I want to explain about the methodology. So first is the selection material. The material we use is first Arduino Uno. The second is sensor MQ135 sensor and Wi-Fi ESP8266, LCD display, potentiometer, jumper wire, breadboard, and resistor. Okay, next, this is the bills for the materials. The total is XT6 ringgit, and this is the block diagram. For the input, we use power supply, MQ135 gain sensor, Wi-Fi ESP8266, and we use Arduino Uno, and the output is LCD display. Okay, as we can see, this is MQ135 module, and this is MQ135 pin out. So in here we also show the sensor specification for MQ135 sensor. The first is wide detecting scope, fast response and high sensitivity, stable and long life. Operating voltage is 5 volt. Detects or measure NH3, alcohol, benzene, smoke and carbon dioxide. So this sensor can be used as a digital or analog sensor. The sensitivity of digital pin can be varied using the potentiometer. Okay, this is our flowchart. The first power supply on and Arduino start running program, and MQ135 sensor detect gas. If the gas was detected at 400 ppm, so the sensor will send signal to cloud and to the internet. So then we use ThinkSpeed. So the ThinkSpeed will show the reading of air quality, and this is our simulation circuit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Luqmanul Hakim bin Abdul Qadir, and now I'm going to do some demonstration on our project. So this is our circuit, which include MQ135 sensor, ESP8266, Arduino, LCD and also potentiometer. Okay, next, when we connect our system, this is what will display on our LCD, and we will know that our Wi-Fi is connected when it is informed on the LCD. Okay, so that's what happened at the LCD, and we can adjust the brightness from the potentiometer. Okay, so for this project, we're going to use ThinkSpeed to display our result. Okay, so before we start the simulation, we need to check our connection. Okay, so for this connection, for this project, I'm going to use this connection which we have already set at the coding, just like from the previous video. Okay, so now as we can see from the screen, we have already obtained some data. Okay, as we start our system. Now I'm going to demonstrate using a lighter to trigger the sensor. Oh, before that, we need to, when our LCD display this signal sending data to cloud, that means we can already use MQ135 to send our signal to the internet. Now I'm going to demonstrate. Okay, so when I apply some gas to the MQ135 sensor, the display will show some result. Okay, we can see now we have already obtained some result. Okay, so if I apply more, we can see it will increase more. Okay, now we can see that it has already shoot up. Okay, from just now it's around 500 something. When we apply the gas, it will shoot up until 739. That shows that our system is working. So that's all from me. Thank you.
Assalamualaikum and a very good evening. So my name is Muhammad Shahrudin Kandid. So I'll be in charging to explain the coding to all the lecturers. So in this coding, we are using the Arduino. So first of all, we need to download the software serial.hash and the liquid crystal.hash from the library. Okay, and then so we put the liquid crystal with the pin is 12, 11, 5, 4, 3, 2. Right. So So we are doing sending data to the uh, World Wide Web. So we're using the server from from the API thingspeed.com. So we get data there. So this is our API key. Okay, this is all key. So if people want to use our coding, so they can replace the channel at the API key. Okay, then we have to connect the 9 to TX and connect 10 to RX. Okay, this is for the ASP8266. And then to begin this coding, we'll be setting up for the LCD display first. Okay, the LCD display first, and then we have to reset our Wi-Fi ESP8266 Wi-Fi. So this is the coding. Okay, this is the coding for 8266 Wi-Fi. Okay, to connect the ESP8266 Wi-Fi to the internet, we have to ask the ESP8266 Wi-Fi to connect it to an access point. So we should this is our access point, and this is the password of our router Wi-Fi, access router Wi-Fi. So if it's connected, it will print the connected. If it's not connected, this message will not come out at the LCD. All right, and then if it's connected, it will go to the next coding, that is the equality sending data to cloud. So once it send data, it will send data to API thingspeak.com. So using the API key here that is being stated that here, okay, it will send data to the API ThinkSpeak Cloud. So from there we can check our data, whether it's getting the data or not.
In conclusion, for our project IoT-based air pollution monitoring system using Arduino, our conclusion is actually to achieve this system can be installed in any place to monitor the air pollution level, which is useful especially in labs because they use a lot of chemicals and a lot of gases are out, so we can monitor the air pollution level in the labs, so it will be safer for them. Next, we can monitor the level from anywhere. So after we install the system, we can use our phone and check the air pollution level. Let's say we are out of the place, we are far away, we can always on our phone and our devices and check the system. Finally, our people with health problems such as asthma, they have breathing difficulties, so they must always be in a good environment which has clean and not polluted air. So this system really helps, because once air pollution increases, we'll be alerted, and our system we can alert them. We can alert all these people so they know what precautions they have to take, and they can always be safe and confident, because the surrounding area they are in, the air pollution level is normal. I mean, there's no air pollution, and it is good for them. Thank you.